Okay, good evening, class, and welcome to MI class for today. We are going to be taking topic number 7. Topic number 7 has been divided into part 1 and part 2. I'll be taking part 1 today for better understanding, so that I will not rush you with that topic. It's a very sensitive topic. It's called forecasting. Let me share my screen with you now so that you can see the topic for discussion today. Okay. The topic for today, session 7, is forecasting. Sorry, let me scroll down. Scrolling down. Sorry. Okay. Forecasting. Sorry, let me use this moment to bring up my calculator so that I will not waste time. While I'm getting my calculator ready, sorry. Just a moment. Slow. All right. Forecasting is the topic for today, and we'll be looking at, in particular, what we call moving averages and lines of best fit, that is there, lines of best fit typographical error. By the end of this topic, you will be able to construct a time series. You also identify and draw the trend line. You will derive a line of best fit using what is called centered moving averages or least square linear regression analysis. These are the things that will be covered in part 1. In part 2, we will go ahead to do what they call additive model and proportional model to make forecasts. So let's look at the nature of time series. Time series. When you hear time, it means movement of the day, the hours, the minutes, they are all time. When we say series, it means something going and reoccurring. So the nature of time series. A time series is a record of data over a period of time. So data could be like sales revenue. That's one form of data. The period of time could be over 1 month, could be over a quarter. So when you are recording the series of sales revenue, day 1, day 2, day 3, to the end of the week, you've collected a time series for 1 week. If you are doing for 1 month, 2 months, 3 months, it's a monthly sales revenue record. As long as something is occurring frequently, it is a series. Now, if that is occurring over time, we call it a time series. Now, time series is a convenient way of representing historical information. Now, historical information are information about the past. So we are bringing things that have happened in the past, and you use a time series to represent them conveniently. Now, in management information and subsequently in PM, we don't usually talk about the past. What we are looking at is the future. So while this time series is a convenient way to present historical information, the most important thing is to use the time series to make predictions about the future. So this is done by continuing the time series forward in time. And so in order for us to continue the time series and make predictions, we have to analyze the component parts. So you'll be asking, what are those component parts of a time series? Now, if you look at the screen here, you see that a change in value of an observed variable in a time series might be due to a combination of factors. Now, those factors are those components that make up the time series. Take, for example, we have two main formulas for time series. We have the additive model. When you hear the word additive, it means you are adding up the data. So we have TS, which means time series. And that time series could be like your sales revenue, could be your cost data, anything, okay? Now, your TS, your time series, is equals to T, which is your trend. So trend is one component, plus your seasonal variation, plus your cyclical variation, plus your random fluctuation, represented as T plus S plus C plus R. So we will learn in our class for today that C and R will not be useful for us. So all we need is just the T and S, which is the trend and the seasonal variation. And I told us today that we will be looking at trend. We will not come to the seasonal variation. We'll do that in part B. So the components will be after today is just the trend and the seasonal variation to form a time series. So in additive model, it means that these two components, all the components forming the time series, are related by addition. You add them together. When you come to proportional, or what we call multiplicative model, we find out that these same components are related when you multiply them. So we're going to see how both of them works when we look at the seasonal variation. Okay, now note that the term seasonal variation has a specific meaning in time series analysis. So when you hear the word seasonal variation, it has a specific meaning. It relates to the variation in each period covered in the analysis. So there are periods covered in an analysis. So if you are doing something weekly, so 1 week is a circle. 1 week is a circle. If you are doing something according to weekly, so week 1, finish 1 circle, week 2, finish 1 circle. That will mean that your data will be arranged in days, either maybe 5 working days or 7 natural days in a week. Then if you are doing something monthly, it's either your data is being arranged in groups of either 30 days or either 4 weeks in a month. So maybe it's 4 weeks. So your group might be 4 weeks. So if weekly are your cycle and you want to get something over a period of 1 month, so you have 4 cycles of weeks. So that's what they call seasonal variation. It means how the trend on Monday different from that of Tuesday, different from that of Wednesday. That's what is covered there. Then if you are doing something according to yearly and you want to look at it in quarter, that means a complete quarter is a cycle, quarter 1 to quarter 4. Or you can look at 12 periods, months, month 1, month 2, month 3, month 4. So when you look at it that way, there is a seasonal variation that makes January different from February, makes February different from March and all that. So these are the sort of things we want to talk about. So, okay. So now let's look at questions requiring time series will require the identification of what they call trend and seasonal variation. So we see that you will always need your T and your S. Random fluctuations, which is the arrow, cannot be predicted and can be ignored. Also, in cyclical variations, we have usually having sufficient data. So you see why we are not using those. Now let's look at the histogram of time series. Now, if you look at the diagram, it shows the trend line with seasonal variations above and below the trend. So you look at a line, so you look at the time, the horizontal here is the time, the vertical is the data that you are collecting over time. So your sales revenue over time. So you see how it moves. All those stars, there are the figures. So this looks like what they call scatter diagram. So you have a scatter diagram here, and look at your line, this line of best fit. If you remember scatter diagram from way back in mathematics, this line is a line of best fit. So you take this line of best fit. How do you get the line of best fit? That line of best fit is called the trend line. This is what you are going to get today. How to do your trend line so that you can use it for prediction. Now, analyzing a time series. There are 2 aspects to analyzing a time series from historical data. First is to estimate the trend line. Estimate the trend line first. The second one is to calculate the amount of seasonal variations, either monthly variations or daily variations. So these things are the things I've been saying. You have to get your trend line first, then you apply seasonal variation. Today we'll be looking at how you can apply your trend line. We'll be practicing how to apply trend line so that when we use it for seasonal variations, it will all become easy for us. The time series can be used to make estimates for a future time period by calculating a trend line. Then either we will add or subtract the appropriate variations for that time, the seasonal variation. So we may be adding or subtracting, they're using additive model, or you may be multiplying or dividing, they're using the multiplicative. Now there are 2 methods of calculating a trend line, because the first thing to do in making your forecast is to get your trend line. So you have 2 options. We'll be looking at the moving averages. after looking at the moving averages, which is the favored method, we'll look at the second method, which is linear regression analysis method. The linear regression analysis method is also good. We will look at how both of them differ, and we'll see how we can use it to make a preliminary prediction. Okay, moving averages. Now, when we say averages, averages are like, when we say what is the average of five boys, the age of 5 boys, all you need to do is add their ages and divide by the number of data. So there are 5 boys, so you divide by 5. So if I ask you what is the average sales for the week, and you know it's 5 working days, you add all the sales for the week, for the 5 days, and divide by 5, gotten per day. So that's average. So when I say moving average, the average is moving. Now let me compare it with when you are doing budgets and you talk about rolling budget. A rolling budget is a budget that rolls from one period to another. This is because, let's say we are doing a budget for 1 year, taking them in quarters. Or let's say we are doing a budget for a week, for 5 days. And now you decided that you've done budget from Monday to Friday. After Monday has passed, enter Tuesday. You will now say Tuesday to the next Monday, so that in all your budgets, Monday is always represented, Tuesday is always represented, Wednesday is always represented, Thursday is always represented, Friday is always represented. Though you have removed the past week, the past date, or the past day, you have added another day to compensate for it. So the circle is still there. That is what we call moving. The average is moving. Moving averages can be used to estimate a trend line, particularly when there are seasonal variations in the data. This technique involves smoothing out fluctuations in the underlying observed data by calculating averages for small group of observations from that data. The size of the small group is related to the type of data. Now, if the data is quarterly, then a 4 group will be used. So because each quarter is 3 months, and in a year, there are 4 quarters. So we need 4 groups. If the data was monthly, we would need 12 groups of data. So 12 data group will represent a complete cycle. Now look at the steps in calculating moving averages. Step number 1, decide the length of the cycle. Now the cycle is a number of days or weeks or seasons or years. Normally, the number of days in a week, if the week is the season, because we said seasonal variations has a specific meaning. So a season is not necessarily a year. A season could be a week. So if the number of days in the week is about 7 or 5, you know that a complete cycle is 5 days. If we say it's weeks, we will not say a complete cycle of weeks, maybe making a month. So maybe you're looking at months. Now you want to look at how many weeks make a month. So 4 weeks gonna be a complete cycle. So you say week 1, week 2, week 3, week 4, complete 1 month. Go to the next month, week 1, week 2, week 3, week 4. If you're looking at months to make the season years, that means we need 12 months. Month 1, month 2, month 3. So a complete season will be 12 months. if you are looking at months as a season, you can either say a complete seasonal month is 4 weeks or 30 days, as the case may be. Now, the cycle might be 7 days when historical data is collected daily for each day, or perhaps I've explained that. Step number 2, use the historical data to calculate a series of moving average. Now, a moving average is an average of all the historical data in one cycle. So for example, suppose that historical data is available for sales over a period of day 1 to day 21, and there are 7 days of selling in each week. That would mean that a week is a season. That means a moving average can be calculated for the first season, which is day 1 to day 7, isn't it? Now, all we need to do is we'll find the average of day 1 to day 7. So what is the middle point between day 1 to day 7? All we need to do is 1 plus 7 is 8. So divided by 2 is 4. So day 4 represents the middle day in the data. Day 4 represents the middle day in the data. So we are going to centralize it such that the average of day 1 to day 7 should be for day 4. Because that's the average. That's the average. That is the middle point. Now, when day 1 has passed, you will now start taking day 2. You will not end in day 7 this time around. So because you remove 1 day, you're going to add 1 new day. So that day 8 is what is representing day 1. It's just like saying Monday last week was June 1, and today is June 8. You are doing a moving average from day 2 to day 8. So you see, you have removed 1 day and you are bringing in the next day 8 to represent that Monday you remove. So you see that Monday is always represented, Tuesday down to Sunday. So you will now calculate the average for day 2. You know that between 8 and 2, day 2 to 8, day 8, the average is 5, is day 5. So anything you will get as the average, you put it in day 5. I believe you understand that. So that is how the average will be moving. So you see the average was starting in day 4. Now as the day moves, you remove 1, you add 8, the average move from 4 to 5. By the time you remove day 2 and you add day 9, the average will move from 5 to 6. So that is how we call it a moving average. The progress continues until all the data has been included. Note that as this is an averaging process, it results in a figure related to the midpoint of the overall period for which the average has been calculated. So because it is an average thing, you are looking at the middle point. Note that it is easier to number each day, month, or quarter in a cycle starting from 1 rather than retaining actual day, name, and dates, and so on. So maybe you are calculating, you start your record from June 8th. So June 8th becomes day 1. Don't call it day 8. If the time you started, everything is in June 8th, so your June 8th becomes day 1 or number 1. If you are starting maybe January, February, instead of using January, February, March, just call it month 1, month 2, month 3, month 4, like that. So if you're starting from June, now June becomes month 1. So instead of retaining the names, January, February, Sunday, Monday, things like that, you use the circle starting from 1. It is easier to imagine it like that. Then step 3, if there is an even number of data in the moving average calculation, there will be a problem. Let's say we are not including Sunday in our, or let's say we are doing monthly, the month is a season, and we say week 1, week 2, week 3, week 4. Okay, now when we calculate the average of these 4 weeks, where will we put it? What is the middle ground? The middle ground will be between week 2 and week 3. That's the problem. That's a problem common when there is an even number of days or period in a season. If there are odd number of periods, then we know that it's easy because one day will correspond to the middle of all of them. But when there is an even number, you find out that it will be between 2 points. So you see that the average will correspond to a point between the middle of 2 periods. A second average will be calculated to smoothen or align it. So we'll do that. For example, a moving average for quarter 1 to 4, I can even say from week 1 to 4, anyone, gives a value which represents the mid-range, the midpoint of the range, and it gives you 2.5. That means it is between quarter 2 and quarter 3. So between quarter 2 and quarter 3 is quarter 2.5. Fine. Now, by the time you remove quarter 1, you start from quarter 2, you are introducing quarter 5. You find out that the midpoint will now move from 2.5 to 3.5. You see that there is nothing like quarter 2.5. There's nothing like quarter 3.5. They don't exist. But we want our data to correspond with actual existing quarters or weeks or season. So all we need to do is to now find the average of what we are putting in quarter 2.5 and quarter 3.5. So when we add 2.5 and 3.5 together, it takes us to quarter 3. So that is how we have pushed it to quarter 3. This step applies when we have even number of observations in a season. Now, step 4, use the moving averages and their associated time periods to calculate a trend line. So run over the steps again. Step 1 is to determine the length of the circle. Could be 5, odd number, could be 4, could be 3. So the most popular in the exams, you'll be seeing 5 as in days, or you'll be seeing 4 as in quarter or weeks. So you determine which is the length. It might not be unusual too to expect 12 for a month, but because it is going to be long, they might not use that in exam. So you just be expecting 5 or be expecting 4, either even or odd. Then the second one is to calculate the moving averages. So you'll be doing them little by little. We'll do an example. Then the third one, if there are even number of data, that is when you apply step 3. Create another one that's smoothing out the data that falls in between one quarter and another. Step number 4 is to get the trend line. Okay, now let's look at a question now. This one says, this is forecast 01, calculating moving averages. A company operates for 5 days each week. So you know this is a moving average question. You've seen 5 days each week. we now know that our complete cycle is 5 days. That means our season is a week. Sales data for the most recent 3 weeks. So they give you most recent 3 weeks. These are historical data. Look at your sales for week 1. You see, they give you Monday, Tuesday, Wednesday, Thursday, Friday. You see, we said that we are not going to look at them as Monday, Tuesday, Wednesday, Thursday, Friday. We're going to be looking at it as day 1, day 2, day 3, day 4, day 5. Then when we get to week 2 Monday will become day 6. So we can even say week 1, day 1, week 1, day 5, week 2, day 1, week 3, day 3. But that may confuse some people. So all you may need to do is, even if they tell you week 3, day 5 or week 3, day 3, put everything in days, because your number of your data are in days. So you say day 1. So we are having day 1 to day 15 here, because these are 3 times 5, 15 days. Fine. They say calculate the moving averages. So how do we calculate the moving averages? So let's get the solution down here. Now look at the solution. Now moving averages can be calculated as follows. Now look at this day 1, week 1. You now present it in a data, time series data, in such a way that it is understandable. Look at it. You will now say day 1, day, and look at the sales. So this is day 1, day 2, day 3, day 4, day 5. As given here, then look at this. So instead of Monday, Tuesday, you are calling them day 1, day 2, day 3, day 4, day 5. Then look at the data for all of these. Now, you are looking for the average. How do you get the average? The average here, let's do it together. The average will take the 78 for day 1 plus 83 for day 2 plus 89 for day 3 plus 85 for day 4 and 85 for day 5. You have your 420. So you can see the 420 that was written down here. So because this is the total value for the week of 5 days, what is the average is to divide by 5. So you say divided by 5, it means 84. That is 84 naira per day. So you see all these sales of 780, 78 down to 85, it can be averaged to mean that it is 84 naira or 84,000, as the case may be, if there are thousands per day. Now, do you notice where it is kept? It is kept at the middle between 1 to 5. So how do we know that 3 is the middle? You say 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is 3. Another way of doing it is to say 1 plus 5. That's the shortcut, which is 6. Now divide by 2. That's 3. For the first way, you just do day 1 to day 5 and you divide by number of observations, which is 5. So it's going to be on day 3. So you see everything is being written down on day 3 here, and it is being associated with a particular day. So we have no problem when it is odd numbers, because they will be associated with a particular data. So we see 84 represents the sales in the middle day of the period, day 3. So you look at it now. In the middle is 89. That doesn't mean that it is 84 that is there, but it means that this is the average and they put it, associated it with number 3. Now let's get to the second one, which is, we've removed day 1 now. and we are adding day 6. So the moving average is going on now. So we have 83 plus 89 plus 85 plus 85 plus 88 gives you, what am I doing? Sorry. 83, wow. 83 plus 89 plus 85 plus 85 plus 88. Sorry. 83 plus 89 plus 85 plus 85 plus 88 gives me 430. So when I divide by 5 days, I'm going to get 86, which I will put on day 4. Let me tell you something now. How do we know it's day 4 we're going to look at? I said it is 2 plus 3 plus 4 plus 5 plus 6, which is 20 divided by 5, gives you 4. Say shortcut, you start with 2 plus 6 gives you 8 divided by 2, 4. So you can take the shortcut. A shortcut of getting this 430 without having to do all of this, having to add all of this, is this. When you have your 420 from the first average, you know you are removing this 78 and introducing 88. Every other thing that was here is already here. So all you need to do is you say 420 minus 78. You remove the day 1, then you are adding 88. Takes you to 430. That's a shortcut so that you don't spend too much time, because this 83 is the same thing as this 83. This 89 is the same 89. This 85 and 85 are this 85 and 85. So the only difference here is we have added 88 here in place of 78. So you remove 78 and add 88. That is how you get your 430. And how do we know it's in day 4? We know that this one was day 3, so you move it 1 day. That's day 4. It's in the middle. So this is just to show you how it is being done. So for the sake of convenience, we assume that week 1 consists of day 1 to 5, and we say week 2 consists of day 6 to 10. Don't go and include Saturday and Sunday that was not given to you and say that is day 6 and day 7. Then you come here and say day 8, because confusion. So Saturday and Sunday are not part of it. So day 6 of the working week is on Monday the next week. Now, look at how it is going to be done. For the 5-day period, all you need to do, you start your week 1, you have your day 1 to day 5 being arranged here. Then your week 2 starts, your day 6 to day 10 figures are here. Then your week 3, day 11 to day 15. You've successfully transformed all of this into this table. Now, that's all. You will now go to your 5-day total. You will now start doing that thing we used to do. You will now add 78 plus 83 plus 89 plus 85 plus 85. You add them, the total will give you 420, which you have kept in day 3, like I showed you here. Then when you divide this 420 by 5, you have a 5-day moving average. This is the moving total. This is the moving average. Then you remove the first day and you add day 6. From what we did, it was 430 we got, which was kept under day 4. When we look at the average, it was 86. Now, building from that example, we will not need to be calculating. I'll just be showing you, you remove your day 2 and you add your day 7. And I told you, look at what we'll be doing. We had 430. So when we remove our day 2 is 83. When we add day 7, we add 93. That's the shortcut way of doing it. We are getting 440, which is this 440 here. We divide by 5, it's 88. So you see, that is how you do until when you get to this point. How do you get to this point? So when you get to this point here, okay, let me see something here. When you get to this 109 as your ending figure, let me see something here. 109 plus 103, sorry, 103 plus 98 plus 95, 1, 2, 3, 4, plus another 95 gives you 500. So you see, the 500 is here. So by the time it moves, it shifts to this side, this will shift to 501. By the time you shift to this side, it shifts to 520. So these 530 and 540 are just put here because we are expecting the results to be in order. So normally in the exam, don't go and put 530 and 540 because there are no 5 data that you are going to calculate to get all of that. So just keep here blank and keep here blank. Just as you kept here blank and you kept here blank. So you see that because you have started from day 3 to put your average, these first 2 will be blank. The last 2 are also going to be blank. That's one way to know that you're getting it. Then your averages, these are your averages as we calculated. So note that the process the process always results in a loss of values for points in time at the start and at the end of the range. So we've lost 2 points here, especially here 2 points. Lost 2 points, especially here 2 points. Just a moment. So it is easy to get our moving averages when we are having an odd number. When we have an odd number, we follow this trend. Now look at the line of best fit. How do we calculate the line of best fit? The trend, which is a line of best fit, is an indication of the general movement in a set of data. In order to make predictions, the trend must be expressed as a straight line. And what is the formula for a straight line from mathematics? We say a straight line is y equals to ax plus b, or ax plus b, where a is the gradient and b the intercept on the y-axis. So the gradient is like the slope. I'm not teaching you maths here, but you need to get that kind of knowledge in order to know that a straight line is just x and y. Now, in order to make predictions, we must express it in a straight line. So how do we make it in a straight line? This means that the trend increases by 2 each day. So this is the trend. This is the trend average. it increases by 2 each day. So it increases by 2 each day. That's what they are telling you. So it is a perfect increase by 2 each day. This means that each moving average actually lies on a straight line. It is perfect. An equation can be found for this trend by taking the first sales figure as a starting point and then adjusting it by the number of days multiplied by 2 to give the following formula. Now look at what they said. You want to find the equation of the trend, you can take this sales, or you can even take this trend line, any of them, but here the question here say you can take this one here. After taking it, you will now say multiplied by 2 because there's a difference here. 2 multiplied by the number of days. For example, so look at the formula here. The 78 is what starts it plus 2x. So this 78 is the minimum point, which is like the intercept in the y-axis. This is your slope, the rate of change, the rate of change, the rate of increase or decrease. So it's increasing or decreasing by 2. So you take it, multiply by the number of days. So each day, if you want to use for 2 days, you say times 2, x will become 2. If you want to do for 3 days, x will become 3. So in this trend line now, if you want to calculate for day, if you want to forecast for day 50, all we need to do is say 78 plus 2 times 50 will give you 178. How do we do it? You start with 2 multiplied by 50 board mass. Anything with brackets goes first, which is 100. Then you add 78 to it, 178. Let's predict for that of day 10. Let's see what's going to happen. 10 times 2, which is 20, and you add 78, gives you 98. So let's see what happened in day 2. Day 10 gives you here 98 is the trend line. 98 is the trend line. So if you do that, so you have calculated your trend line for 98. All right. This, of course, assumes that the sales will continue to grow at 2 naira per day on average. Now, this trend line can also be used to calculate the seasonal variations. Now, in this example, the daily variations in sales above or below the trend line. We'll turn to that later. In turn, this can be used to adjust the forecast value of the trend line to take advantage of whether day 50 is a Monday or day 50 is a Tuesday, Wednesday, Thursday, or Friday. So we'll do that when we talk about part 2 called the seasonal variations. So suffice it to say that we are looking at trend line using moving average. Trend line using moving average. So we've talked about the steps to calculating the trend line, decide the number of days. In this example, we have 5 days as the number of days in a season. Then we said the second step is to calculate the average, moving average, starting from day 1 to the end of the season, which is day 5. Calculate the average, put it in a middle point, then you get to remove 1 day, you add 1 day behind. You remove 1 day up, add 1 day behind. You calculate another trend, put it in day 4 and all that. When we have even number, we'll do something different. Then after that, we'll now calculate the line, trend line, which is called the line of best fit. So when in the exam, they tell you what is the trend line, they might use another language, what is the line of best fit. They might even say, what is the trend? And it didn't say line. No, it is still the same thing as trend line. Let's look at an example when there are even numbers. When there are even numbers of seasons in a circle, the moving averages will not correspond to an actual season. Now, when this happens, it is necessary to take a moving average of the moving average. It's interesting. You take an average of the moving average that does not fall in line with a season, take the average to get another average that will fall in line in order to arrive at a value that corresponds to an actual season of the year. Let's see an example. The example here, example 2, you see that the following quarterly sales figure have been recorded for the company. So look at 1 year, it's the season is quarters. So a quarter make a season. So there's first quarter, second quarter, third quarter, 4 quarters make the season of the year. So you see, because we have 4 quarters, we'll have 4 moving average. We call it 4 quarter moving average. When we have 5 days, we are calling it 5-day moving average. So this is 4 quarter moving average. Now, for the sake of convenience, quarter 1, 2, 3, 4. Then we say for year 2, we have quarter 5, 6, 7, 8. Then for year 3 is quarter 9, 10, 11, 12. So we have 12 quarters here. So what do? We are asked, required, calculate the moving averages value for each quarter. What we are going to do? All of these figures are in thousands. So you see they are in thousands here. We'll arrange all these figures like we did in the first one, quarter 1 to 12. So we have arranged them all. So you see, year 3 quarter 4 is the quarter 12 figure. So that's it here. So that's fine. So you observe that there are spaces. So what we say, okay, now watch. Let's start with quarter 1. Quarter 1 is 20. Quarter 2 is 24. Quarter 3 is 27. And quarter 4 is 31. This is 102. So you see, that is where we got our 102 from. So what do? There are 4 quarters. We divide the 102 by 4. We have 25.5. So where do we keep this 25.5? How do we know what quarter to use? I told you before, you add 1 plus 2 plus 3 plus 4 gives you 10 divided by 4. 4 will give you 2.5. Another way of doing it is 4 plus 1, which is 5, divided by 2, 2.5. That means it will be between half of quarter 2, between 2 and 3. The midpoint between 2 and 3 is 2.5. So that's why you are seeing a space here, and we are putting our 25.5 in between. Now, that means this 25.5 does not belong to a quarter. So the next thing you do, you remove quarter 1, which is 20. So we'll go back to our 102 we've gotten before. We remove quarter 1, which is 20, and bring quarter 5. Sorry, quarter 5 is what? 35. See, you're getting 117. Instead of starting to, so you have to use your pencil now. As you are marking this one bad, you are marking this one good. So that will help you to know which one to take quickly so that you do not waste time starting to calculate again. So you say 117 divided by 4 will give you 29.25. So it's going to be between quarter 3 and quarter 4. How do we know? Because quarter 5 plus quarter 2 is quarter 7. Quarter 5 plus 2 is quarter 7 divided by 2 is 3.5. So you see, it's going to be in quarter 3.5, the middle of 3 and 4. So you have your 117, you've removed quarter 1 and 2. Let's remove quarter 3 by saying minus, let's remove quarter 2, minus 24. You are adding quarter 7 by adding 44 plus 44 gives you 137. Sorry, we got this by removing quarter 1. We'll remove quarter 2 here to get this, sorry. Let's start again. 117. Let's remove our 24. Give me 93. So I'm removing quarter 2. So it's going to be 3, 4, 5, 6. So I'm adding 3, 4, 5, and 6. Okay. Yeah, it's 2, 3, 4, 5. So yeah, it's 3, 4. So I'm adding 39. Sorry. So I'll add my 39. Yeah. That's how I got my 132. If you are just in doubt, using your pencil, as you remove this, you add this. As you remove this 24, you add 39. So the next one we will remove 27, we'll be adding 44. Let's see it again. We remove our 27 and add our 44. We get the next figure, which is 149. So that's how we'll be doing it to be fast in the exam. And we do that and you divide and you put it in between. That is the first step to do. So this thing now is similar to what we did in the first one when we have our 5-day moving total and 5-day moving average. But the difference now between this and that one is that the average, the moving average, does not belong to an actual season. Meanwhile, in the 5-day moving when it was odd, it belonged to an actual data season. So what do we do now? Now look at each of the moving average figure line up opposite a point between 2 quarters or seasons. For example, seeing quarters 1 to 4 sits between quarter 2 and 3 at 2.5 and all that. What do we need to do? The next is to get a second average to do an average of the average. So now look at the quarter and your sales as before. If you notice, this 64 is still here. But now, let's jump and remove this, because we're not looking at this total anymore. We're not concerned about these totals now. So that's why I didn't put this line. We are not concerned about here. 25.5, 29.5, we are concerned about it. So you can see that 25.5, that doesn't mean I cannot put the other one omitted. If you want to put the other one, it's fine. In fact, this should have been the full table. But for the sake of illustration, I had to do it this way in class. You see, your 25.5 does not belong to quarter 2 or quarter 3. It's in the middle. The same thing, your 29.5 does not belong to quarter 3 or 4. So what do? You find an average of this and this. So you see here, you say, find the total between 25.5 and 29.25. When you find the total, this becomes 54.75. So now, where do you think the total will be? 2.5 and 3.5. What is the average? What is the middle point? 2.5 plus 3.5 is 6 divided by 2. You see, the average is 3. So between 2.5 and 3.5, the average is this 3. So you see everything is lining up here nicely with quarter 3. Now when you find this figure, you have to divide it by 2 because you've taken 2 items. So all we need to do is to say 54.75 divided by 2 gives me 27.38. So that's how we got our 27.38, which is now our average, which is sitting at quarter 3. So now, all what you are doing is to find a way to eliminate this one here and this one here that does not belong to a quarter to get this one, which will now be used, that belong to this quarter. So the same thing you will do for this quarter, because you remove one now and you bring this one down, you add these two together, you get a total that will be in the middle, you get an average that will be in the middle. So you are doing average of averages. So you are doing average of this average. That's what it means. So using that, you would have done averages and averages and averages, and you find out that the last two have nothing here. So between season 9 and season 10, quarter 9 and quarter 10, we have these two figures here. So when we add them together, I have a figure here, find the average, and I got this figure here. So you see, you have successfully done a moving average that belongs to a quarter. So you see now that the moving averages in the right-hand column correspond with an actual season. These moving averages are used to estimate the trend line and the seasonal variation. Now, how do we get the line of best fit? The line of best fit, I usually advocate the use of high and low method. Rather than that first one, you just note that it's increasing by 2 and all that. I usually advocate using line of best fit, high or low method. I don't know if Prof. Taiwo have taught you high or low method, but I will teach you a form of high or low method here that will be used for line of best fit. As explained earlier, the trend is an indication of the general movement in a set of data, but in order for it to be used to make predictions, it must be expressed in a straight line. The first moving value can be used as a starting point in the equation. The first moving value. So what is that moving average value? The first moving average value. So what's the first moving average value here? Is supposed to be, this question now, supposed to be either here, okay, sorry, supposed to be either here, is the centered moving average value, because this is the one that belongs to this quarter. So we can't take this. Yeah, we can't take this. So we are now also wanting to take the sales figure. So the best is to take, because you are looking for the line of best fit of this moving average. So you take this final one that you've just gotten. That will become your first point. So we say the first moving average value can be used as the starting point in the equation. Yes, that is the smallest value, the first point. Now, one way of identifying the slope. So, the other way we did that before we got to, we identified the slope, the rate of change. But in the case of this, when it is not readily available, like look at this first one, that you saw that it was easy to know that they change 2 per day. Okay, we saw that it was changing 2 per day is to find, so you know that the rate of change is 2 per day. But in the case of this second one, you cannot determine the rate of change. So all you need to do, look at it. How do you know that 31.13, if you minus 27.38, is 3.75. But when we do the second one, if we add 3.75 to 31.13, it won't give you 35.13. So you see, the rate of change is not the same. So all we need to do is to look for the first figure here, 27.38, as the beginning of our equation. Then look for the slope. The best way of looking for the slope is to subtract the lowest moving average from the highest moving average. That's what is called high or low. So all you need to do is bring your highest moving average. We got it from quarter 10. So from quarter 10, see, 53.13 is the highest moving average. You put it down here. Then less the lowest moving average in quarter 3, 27.38. When you say this minus this one will give you 27.75. Now you ask yourself, how many quarters are there between quarter 3 and quarter 10? Why are we taking quarter 3 and quarter 10? Because our data, the lowest value is in quarter 3, the highest value is in quarter 10. So you ask, how many quarters are between 3 and 10? All you need to do is count. Between 3 and 4, we have 1. Between 4 and 5, we have another one, 2, 3, 4, 5, 6, and 7. So that's it. So we have 7 quarters between 3 and 10. Another way of doing it is just to say 10, quarter 10, minus quarter 3 gives you 7. So 10 minus 3 gives you 7 quarters in between them. So all you now do is, once you know the quarters in between them is 7, you simply say 27.75, 27.75 divided by 7, you have 3.96. 3.96. So this 3.96 is your slope. So your equation now is your lowest value, which is your intercept, plus your slope multiplied by x. So that's it. That was also kind of the same way we could have done it here. This is 84. So what is your highest figure is 104 minus lowest figure 84. You see it's 20. So what is the between day 13 and day 3? I simply say 13 minus 3 is 10. So I say 20 divided by 10 is the same way I got the 2. Same way I got the 2. So you see that either you say your 84, you can decide to say 84 plus 2x, or you can decide to say your 78 plus 2x. But I prefer sometimes you use 84.2x to estimate your value here. Okay, so let's go back here. So let's look at from the previous example, but before we go into that, care must be taken in using this equation. In the first one, when we use 78 as our starting point, we know it was in Q1. When we use 84, we know it's going to be from Q3. In this formula, because our lowest figure that we got here was in Q3, everything you are doing should be calculated in reference to Q3, because that was what brings the lowest figure here. And that was what we use in getting the slope. Okay, if we want to find a strength sales figure for Q4 in year 4, what do we do? Q4 year 4, what do we do? Q1 year 1 is Q1. Q4 year 1 is Q4. In year 2, Q4, we say is Q8. In year 3, that Q4 is 12. And so in year 4, it's going to be Q16. So you see, this corresponds to Q16 in the example. And we said, how many quarters are between Q16 and Q3? You simply say 16 minus 3, which is 13 quarters. So 13 quarters is involved. So what is our starting point? Our starting point is this constant here, 27.38, plus this slope multiplied by the X value. So all we need to do, what is your sales in Q4? It's going to be this figure here multiplied by this man here times 13 quarters in between. So this X is the 13 quarters in between. So you will not go and put Q16 here, you put 13 quarters in between. So all you now need to do is 13 board mass multiplied by 3.96, get a figure there, then you add your 27.38, get your 78.86. That is your sales for Q16. So you see now, we've done line of best fits using high or low method, which I say is what I prefer. Each time you're doing your line of best fits, whether they are predictable or not, use high or low method so that you would always be using it. Always be using it so that you'll not be asking, which one will I use? Use your high or low method. Look at your moving average, the last moving average you calculated. What is the highest figure? Which quarter does it relate to? What is the lowest figure? Which quarter does it relate to? Find it. How many quarters are in between? You divide it by that, you've gotten your slope. Then all you need to do is take the lower figure, the lower quarter figure as your beginning point, and you say plus your slope, which you've calculated, multiplied by X. X is the number of quarters in between the figure that you're going to be the quarter you're going to be forecasting from, and the smallest figure, and the smallest quarter that gave you that particular slope. I believe you understand that. Let's look at another way of calculating line of best fits. Now we look at high or low method, which is from moving averages, get your high or low method. Another one is the least square regression analysis. So this is another way of learning your regression analysis. Now, just in case we do not take regression analysis, or we do not formally teach you as a topic, regression analysis is the same regression analysis. High or low method is the same high or low method. Now, this technique has already been explaining context of cost estimation. Maybe Prof. Tai would have used it, but it can be used to construct a trend line for forecasting purpose. The time periods must be numbered sequentially, starting from either 0 or 1 to provide for the value of X. So let's see. Now, this is the same example we are given before, the same examples. Now let's see how we can construct your least square regression. So our X, since they are quarters, we take it as quarter 1, quarter 2, quarter 3, quarter 4, down to quarter 12. So year 3, quarter 4 is quarter 12. Fine. Then your Y is your sales value, which you are trying to predict, which are all these figures down to 64. You can see it down here. Then the next thing to do is to calculate X square. X square. So you just note it. How will you know what to calculate? Your formula is always given to you in the exam. You are given to find B and to find A. So you can see that in your formula there is XY. So that means you need to get X, you need to get Y. That's okay. You see that and you need to get XY. There's XY separate. So you see that's why there is XY here. Then your formula says X square. So you need X square. Your formula says X, then square. It's a different thing. I will show you. So after doing all of this, what is your X square? You multiply this one by itself, square it. Now what is your XY? You say 1 times 20 gives you 20. The next one, 2 times 48, 24 will give you 48. Meanwhile, 2 square will give you 4. You come here, 3 square will give you 9. 3 times 27 will give you 81. Like that. When you've done with that, you now find the total, because this sigma here is sum, is total. So we need them. So X, sigma X is 78. So when you add all the quarters together, they give you 78. Sigma Y is the sum of everything here from 20 down to 64, gives you this. Then you are looking for X square. Sum of all the X squares give you this. XY, the sum of all the XYs give you this. Now, you'll now look for your B. What is your B? Your B is your slope. How do you get your slope? Your slope is your B. They say it is N. This N is the number of observations. There are 12 quarters, so there are 12 observations. That's why you are seeing this N here, the same thing as this 12. What is your sum of XY? So you go to where you have your XY, is 3795. You put them here. Then there is minus your sum of X alone is 78, and this thing is multiplication multiplied by your sum of Y. Now all divided by number of observations, 12, multiplied by X squared. Look at your X squared, 650, minus X, sum of X, then you square the result. So look at your sum of X here, 78, you now square it. This is different from this. This is x squared as a sum of all your x squares value. This is the sum of all your x, and you're now squaring them. You're going to be getting different answers. So what you now do, let's do it together. I prefer to do it like this. Look at the numerator. You say 12 multiplied by 3795. Got in your figure as I got this 45,540. No, 45,540. Done that. Do the second one. 78 multiplied by 496. See, we've gotten 38,668. You do the denominator, 12 times 650, we got 7,800. That's fine. Then you now say 78 square. The same thing as 78 times 78. If I'm changing this thing to scientific, so that's the same thing here. If I'm coming here to do 78 square, it's the same thing here I've gotten. So all you now do is to go to the numerator again, 45,540 minus 38,688. See, I've gotten my 6,852. I'll come down here, 78,000 minus 6,084. I have the denominator. So I'll come again, numerator, 6852 divided by denominator 1716. I'm getting 3.99. That is my slope. Now, what will be the intercept, the smallest figure that we will use to start our trend line? Is your A. And we say our A is gotten as this, sigma y over n all over b sigma x all over n. So you see, you look for B first before you look for A, because you need the value of B to get your A. Don't go and look for A first, although they will give you A first, then give you B second. But you know that you cannot do A without getting B. So look at your sigma y, which is this figure here, 496, that's what is up here, divided by 12, then minus your B, which you've gotten 3.99 is here, multiplied by sigma x, 78 divided by 12. So let's do it together. I will say 496 divided by 12. I'm getting 41.33 to 2 decimal place. Second one is 3.99. Sorry. 3.99 multiplied by 78, then divided by 12, 25.94 to 2 decimal place. So let me make it to 2 decimal place here. Sorry. So let me do it. 41.33 plus 25.94. You are getting, sorry, it's minus, sorry. 41.33 minus 25.94. You see, you are getting 15.39. 15.39 is the A value, which is the smallest point you are going to use. So look at the equation of a line. Y is your intercept, which is the smallest value you are going to use, multiplied by your slope times the x. So this is your equation of the straight line. Look at it carefully. Now let's compare them. Lines of best fit compared. Now, care must be taken when comparing sales value that you predicted by each approach. You know, in the first one, the centered moving average approach results in loss of data from the ends. You know, we lost from quarter 1, quarter 2, quarter 3. You see, we lost quarter three's data, and quarter one, quarter two, sorry, started from quarter three, and we ended at quarter 10. We didn't go quarter 11 and quarter 12. There are loss of values. So that's one thing you should know about the center moving average approach. So the first point on the straight line is quarter 3 of year 1. This becomes the value where our x is 0. That's what we should know. Everything is in relation to quarter 3. So your quarter 3 starts the whole thing. In the least square method, there is no loss of data. Everything started from quarter 1 and we ended with quarter 12. So the A value is found where the straight line cuts the y-axis at the point where x is 0. So this point here, this 15.39 is the point that cuts the y-axis at the point where x is 0. If you do mathematics very well, you know that's the intercept. So you say that this is 1/4 behind the first observation. It is difficult to visualize at first, but if you study it, you will observe. Now, if you look at it here now, look at the lines of best fit compared. You see, we have quarter 1 to quarter 1, quarter 2, quarter 3, quarter 4 for first year down to the third year, which we call them x is equals to 1, 2, 3 to 12. This is least square method. Look at your y value. Look at the formula we used. You see the difference here. You still have your 3.99, here is 3.96, almost closely. And you see here that starting point is 15.39, here is 27. So it's because you look at it, almost similar. Quarter 3 is almost similar with quarter 3 here because of approximation. Almost similar. But you see, we started from this point. Our point here is from year 1. There is a loss of data here. So you see, here becomes 0. So here becomes 9. 9/4 between the two of them. Okay, see here, 9/4 between the two of them. So you see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So between quarter 12 and quarter 3, there are 9/4. All you need to do is say 12 minus 3 is 9. Now, between quarter 1 to quarter 12, there are 11/4. There are 11/4. So you see now, but here, you just take, okay, using this method, there is no 0 here. But you see there is a 0 in this place to show that we are having quarters in between. So now if you want to predict forecast for quarter 13, what do you do? So let's see how we predict for quarter 13. The line of best fit, all we need to do here is we say quarter 13, you say 3.99 multiplied by 13 to give you 51.87 plus 15.39 gives you 67.26. 67.29 here, approximation error. So your quarter 13 here is your quarter 10 here. Is your quarter 10 here. So when they tell you when they tell you year 1, quarter 4, how do you arrange it? How you arrange it is year 1, quarter 4 is quarter 13. So quarter 13, yes, it's quarter 13. But between 13 and 3, how many quarters are in between? It's 10. So you say 13 minus 3, so it's 10. So all you need to do is 10 times 3.96, now plus 27.38. You see, you got in, sorry, let's do it again. 10 times 3.96, which is 39.6. If you add 27.38, you see, you got 66.98, which is your quarter 13 figure. And you know there are 10 quarters in between. And let's do this other one again. You know that you are doing 3.99 multiplied by 13 plus 15.39. You see, you are getting 67.26. 7.26 is supposed to be here. I just decided to do it again for the sake of seeing if there's error. So you see, either of these lines can provide a basis for further analysis. They are giving you almost the same thing. So you can use any of them. So either of these lines can provide a basis for further analysis to find using the seasonal variation. So this topic continues using the trend data found by the centered moving average method rather than the regression method. So it means that when we are going to be going to topic number 2, we'll be building up on what we got from the moving average method to work. Then I'll be giving you an assignment on how to give me your seasonal variation building up from centered moving average trend line. I will also give you an assignment on regression analysis. So you need to use this period to know it. So the next class, which is going to be on Wednesday, you are going to see us doing seasonal variation. So I'll call it topic. This is topic what? Topic 7. I'll still call it topic 7B. That's what I will call it, topic 7B. So that you will not think it's a different topic, topic 7B. So we have seen how to construct a time series, identify and draw the trend line. We have seen how to derive the line of best fit using centered moving averages or least square method, this square regression analysis method. Next class, we are going to be looking at the additive model and the proportional model. Any questions so far? Let me see. Any question? As usual, there is no question. I believe we all understand this topic. Go back to the past questions and see both objective and theory questions to see how it has been tested in the exams and see how you can attempt to answer it. I'll see you in the next class on Wednesday. So come prepared when we'll be completing this topic. Meanwhile, Prof. Tai will take you on Tuesday. Any question, send it to me either through the WhatsApp, call me, send me personal message. Thank you so much and have a nice day.